Welcome to my channel AIM Chemistry Learn Chemistry with Dr. Poonam. In previous videos we have already discussed about calculation of pH for strong acids and strong bases. In this video we will calculate pH for weak acids. Student, have you ever wondered why weak acids even at the same concentration as strong acids have higher pH? So in this video, in detail, we will break down step by step what is meant by weak acid, what dissociation constant means, and how we calculate its pH using simple formula. Because pH of weak acid can't be calculated just by knowing the concentration. To calculate pH of weak acid, students, we need extent of dissociation or extent of ionization, and that extent of ionization we can find out by one term, that is dissociation constant Ka. This is a new term for you. So when we calculate pH for weak acid, we need to know dissociation constant for weak acid. So the first thing we will understand what does mean by weak acids. What is mean by weak acid? Weak acid. In previous videos we already discussed about weak acids and strong acids. So here in brief I will give you idea about weak acids. Weak acid is an acid that does not completely ionize in water. Means it is partially dissociate into its solution. So weak acid releases only small fraction of H plus, small fraction of H plus ion. Just we will discuss one example, student. If take example, it's a very common example, ethanoic acid. Ethanoic acid dissociate, it is acid, so it dissociate into H plus ethanoate ion, but extent of ionization is very less. So in its solution, student, we can find hydrogen ions, ethanoate ion, as well as we will see undissociate ethanoic acid, and this is the reason we called it weak acid. And this double arrows, we know that this shows a partial, it is equilibrium, but here student it's a partial dissociation. Now, so again question arise, when there is a small dissociation, how we can calculate pH of weak acid? So to calculate pH of weak acid, we should know dissociation constant. So first thing, student, we will discuss what is mean by this dissociation constant, and it is abbreviated as Ka. Let us take generalized example. This is an acid, weak acid, Ha. As it is acid, it dissociates into H plus ions and A minus ions. Now as it is a weak acid, so extent of ionization is less. So on this equation, students, we will apply law of mass action to find its equilibrium constant. So here I will write Kc. Kc is equal to, as we know that when we write equilibrium constant, so it's a product of concentration of products divided by reactants. This is equilibrium constant for this expression, but we are writing this equilibrium expression for weak acid, so these Kc terms we can write it as a Ka, because it's a dissociation constant of acid. It is the equilibrium constant for an acid, so we will write in terms of Ka, and this is the equation by which we can calculate dissociation constant of weak acid. So student, how we can define dissociation constant? This is a dissociation constant or ionization constant, and is the equilibrium constant for chemical reaction in aqueous solutions involving weak acid. So we need to focus on, student, this weak acid, and this weak acid mainly represent acid strength. This dissociation constant, it mainly represent acid strength. As this, you should know that when Ka value, dissociation constant value, is high, acid is strong. Acid will be strong. When dissociation constant is smaller, acid will be weak acid. Here there is a less ionization, partial ionization, so we need to find out extent of ionization. So we use this equation, that is dissociation constant is equal to product of concentration of product divided by product of concentration of reactant, student. See, now from this equation, how we will calculate pH? Maybe you will find in exam some problems to calculate dissociation constant of weak acid with provided concentration. So this equation you can use directly. But when you have to find out pH, we need to rearrange all these equations and some changes will be there. Let us start. See, now as dissociation constant equation is equal to concentration of H plus and concentration of A minus divided by concentration of an acid. Here, student, we need to keep one thing in mind. As extent of dissociation is very less, so concentration of H plus is equal to concentration of A minus. So just we need to put this A minus, we need to put this H plus instead of A minus. So if I will write this equation number 1, then your Ka equation, if H plus is equal to concentration of A minus, so just put this H plus instead of A minus, and concentration of acid as it is, and H plus ion, it is equal to H plus square and concentration of acid. So this is the equation, student. By using this equation you can calculate again value of dissociation constant, but we are mainly focusing on calculation of pH. So to calculate pH we need to rearrange this equation to calculate value of this H plus. So see, first we will calculate this H plus. So H plus square is equal to dissociation constant into concentration of acid. It means concentration of H plus is equal to under root of Ka into concentration of an acid. So this is the equation, student. By using this equation we can calculate H plus ion concentration in given weak acid. So this is your equation number 2. Now this is very simple. After getting H plus, it is very easy to calculate. So pH is equal to negative logarithm to the base 10 concentration of hydrogen ion. This is your, student, third equation. By using these three equations, this is the actually we are deriving hydrogen ion concentration equation. By using these three equations, students, it is easy to calculate pH of weak acid. So what are the key formulas? One more time I will write here. As this is weak acid, we are finding its dissociation constant Ka is equal to concentration of H plus into concentration of A minus divided by concentration of an acid. This is your number 1 equation. If problem is related to dissociation constant, we can use this equation, but here concentration of hydrogen ion and formed negative ions are equal. So we can rearrange this equation, or we can modify this equation to Ka is equal to H plus square and concentration divided by concentration of an acid. This is your second equation. By using this equation, you can calculate dissociation constant. Now just rearranging, as student you should know concentration of H plus is equal to considered as concentration of A minus. Now we need to rearrange this equation. H plus square is equal to dissociation constant into concentration of an acid. So it means H plus is equal to under root of Ka into concentration of acid. This is a very important equation, student. Every time you do not have to derive all these things. Whenever you see weak acid, as soon as you see in problem weak acid, directly you need to use this equation, that is concentration of hydrogen ion is equal to under root of Ka into concentration of an acid. After getting concentration of H plus, you can easily calculate pH, and pH is equal to negative logarithm to the base 10 concentration of H plus. Whatever value you will get it here, just put this value into this equation. This is your fourth equation. So from this you can easily calculate pH of weak acid. Now student, we will discuss one example, so it will be more clear how to get pH of a weak acid. We will solve some problems where we are going to calculate pH, dissociation constant as well as pK for weak acid. So without wasting time, directly we will start problem. So now this is first problem, student, where first we will read it and we will find what is given in this problem. So calculate the pH of weak acid, that is this is HX acid, of concentration 0.1 molar. Molar means this is mole per dm cube, and dissociation value is given, that is K is equal to 4 into 10 to the power minus 5 mole per dm cube. Now as we have already derived formula, but shortly I will tell you here formula how to derive. For this you should know how to dissociate acid. This is weak acid but dissociate partially, so it will be H plus aqueous plus X minus aqueous. So after applying law of mass action, you will get equation for dissociation constant, that is equilibrium constant. Ka is equal to product of concentration of product, it's X minus, X minus, and concentration of reactant. Now we know that, students, this is very less dissociation, so concentration of whatever ionized ion are, they are in equal amount, so concentration of H plus is equal to X minus. So here we can take it as a Ka is equal to H plus, X minus is equal to, we will take H plus, and already we derived this equation, but again just for revision purpose I am telling you. So Ka is equal to H plus square over Hx. From this we can get equation, this is for Ka, and here you will get equation for just a rearrangement, student. Ka into concentration of acid given, and if you want to calculate H plus, this will be equal to under root of Ka into concentration of acid And after calculating H plus, we will calculate pH. We need one more formula. pH is equal to negative logarithm to the base 10 concentration of H plus. So note down these two formulas. Already we derived this formula. We need this formula. Whenever you see weak acid, student, your formula should be H plus is equal to under root of Ka into concentration of given acid. And later on you need to put formula for pH. Solve from given values. Ka is equal to, I will write one more time formula, Ka into concentration of acid. Just we need to put, sorry, this is H plus. H plus is equal to concentration, because we need to find out concentration of H plus, students. So just check what is the value of Ka, that is 4 into 10 to the power minus 5. Don't forget under root sign. Power minus 5 into concentration of acid given is 0.1. So just directly in calculator you can calculate. You will get value that will be equal to, here also student, or simply you can write here 4 into 10 to the power minus 5 into 10 to the power minus 1 is equal to 10 to the power minus 6. So directly you can take a root of 4 is 2, and here 10 to the power, sorry, why I am putting under roots. After taking under root, 2 into 10 to the power minus 3. You are calculating concentration, so note down unit mole per cubic decimeter. So in a simple way, student, you got concentration of H plus. Just for calculating pH, put it into this formula. Directly you get it from calculator. Minus 3. Calculate, students. So you can pause video and you can calculate. It is approximately equal to 2.7. You can cross check it. After taking pH you will get after taking log you will get 2.7. So note down, students. Now second problem, calculate the pH of 0.1 mole per dm cube of ethanoic acid and Ka value is given. So same, student, here also you need to calculate pH. We will go by same equation, but here I will put direct equation. Here we can directly take equation, that is H plus is equal to Ka into concentration. This is ethanoic acid, student. So don't forget to write what acid is given. So if ethanoic acid is given, write down concentration of ethanoic acid. And value of Ka is 1.74 into 10 to the power minus 5 into concentration of CH3 is 0.1. So it is equal to 1.74 into 10 to the power minus 6. So you can calculate from your calculators. You will get value 1.32 into 10 to the power minus 3 mole per dm cube. And later, student, after getting your H plus concentration, it is very easy to calculate pH is equal to, put into formula negative log 10 H plus concentration. So negative log H plus concentration is your 1.32 into 10 to the power minus 3. So calculate, students. After calculating I will get 2.88. So this is pH for ethanoic acid when pH concentration is 0.1, and dissociation constant value you will find same, student. Now third problem, calculate the Ka and pKa values of 0.100 mole per dm cube of ethanoic acid at 298 Kelvin, which forms 1.32 to 10 to the power minus 3 mole per dm cube, it should be dm cube, of H plus ions in solution. So students, here you need to calculate value of Ka and pK. So as I will tell you, this is ethanoic acid. So you write ethanoic acid as a CH3. It means 2 carbon atom. So they will dissociate into CH3 COO minus acetate ion and H plus ion. So Ka is equal to concentration of products and concentration of reactant. Why I am writing here in detail? Because sometimes they ask you to write a dissociation of given acid. So that time you should know this equation and how to write this Ka expression for any acid. Now student, here you need to calculate Ka. So for calculating Ka, what is given? Given is H plus concentration in acid. As we know that the H plus is equal to, here this is weak acid CH3 COO minus. So your equation, use this equation directly, H plus square concentration of CH3 COOH. And student, put value of H plus. Value of H plus is 1.32. 1 minute. Is equal to 1.32 into 10 to the power minus 3 square. Don't forget to write this square, student. Many students forget this square. And 0.1. Calculate this Ka. And this is ethanoic acid, so its value you should know, that is 1.74 into 10. In previous problem we also, you will get this value, student. Check 1.74 into 10 to the power minus 5. After you will get 10 to the power minus 5. So this is value for Ka. Now if you want to calculate pKa, your value of Ka is equal to 1.74 into 10 to the power minus 5. And we know pKa is equal to, when we take negative logarithm to the base 10 Ka, you get pKa value. So here student, negative log to the base 10, 1.74 into 10 to the power minus 5 is equal to, you can calculate, you will get value 4.76. So pKa is equal to 4.76. So in this simple ways you can calculate Ka and pKa. Now